GED students, welcome to Math 144 Club, the math class where we work on mixed math review for the GED test. We're hitting those students who just need that little extra push in order to pass their test. They're right there at that 144 score, and we want to get into that passing range. Today we are going to be looking at one of the GED's favorite topics. I told you they love algebra, and their favorite part of algebra seems to be slopes, lines, and functions. So that's what we're going to be looking at today. And I've got a variety of very typical GED style problems to look at. So when we do these examples today, it's going to look a lot like it looks when you take your GED test. I have a cheesy math joke for the day, you guys, because what are we talking about today? We're talking about graphing lines. Let's get started. Which point on the graph is represented by the coordinate pair -4, 0? So what are they asking me to do or to find?
They want us to find the point on the graph. Which one?
Absolutely, we're graphing points.
I guess it's B.
Beautiful. So a lot of students mix up when they look at this, especially when zeros get involved, they get mixed up. So super duper important to remember that points are in alphabetical order. One of my coworkers teaches that first you get your X and then you question Y. But anyway, it's X first and then Y. So yes, this X value is a horizontal movement. X movement is horizontal. So nice job, Manal. It's saying move -4 in the horizontal direction. So starting at 0, I'm to move -4 in the horizontal direction. And then this says no movement in the vertical direction. Don't move up or down. And so I am good to go. Point B, very nice. Now, the most common incorrect answer is D, be careful. This has no horizontal movement, but has a downward or vertical movement of -4. Wonderful. So yeah, I agree. Nice job, Manal. B is the correct answer. So this is about as simple as these concepts get on the GED. So that's nice. It's nice to have something that's actually tested at a simple level. We can use that.
Yes.
Look at this example here. It says, which of the following relations is a function? Okay, guys, as usual, what are they asking me to do or to find?
The function?
Absolutely, the function. Which one of these relations are a function? So, well, here's one of the few things on the GED that you could not just puzzle out. Either you know what a function is or you don't. The function is a relation in which each input value, guys, when I say input value, do you know what variable, what letter mathematicians usually use for input values?
Either X or Y.
Input is usually the X. So it's a relation in which each input value, each X, is mapped to 1 and only one Y. So I get a flood of students in my classroom. Some of them are mine, some of them are other instructors, but who are about to go take their test. They always walk in and say, Kate, I'm about to go take my test. What should I remember? And I always say to them, do you remember what a function is? It is the easiest GED concept. I could teach it in 3 minutes, and yet it's all over the test. And so it is such a quick score boost. And so I'm like, do you remember? Okay, so it is a relation in which each input value, each X, is mapped to 1 and only one output value, 1 Y. Basically, if we put in the same problem, we always get out the same answer. So let's consider relation A and decide if this is a function. Okay, look at the input values, the X's. Do we have a case where each input value, each individual X, is mapped to a different Y? Or do we have a cheating, lying, scumbag X? Well, if you take a look here, you can see I have an X value of 1 and it's mapped to a 4. And then look at that, here I have an X value of 1 and it's mapped to a -4. I have the same X value, the same input, mapped to different outputs. This is not a function. It fails the function test. For it to be a function, the X's must be faithful. And that's my bad joke I always make about this. I said the X's should be faithful. If they had been faithful, they wouldn't be your X's, right? So you cannot have the same X with 2 different Y's. It's a total double standard, just like in the world. It's only the X's that we care about when it's a function anyway. Nobody cares if the y's repeat. So then let's look at relation B. Relation B looks a little different. We don't have x's and y's labeled. First of all, what is this? What am I looking at, you guys? What is that thing?
4, 5.
It's 4 points. Yeah, we have 1, 2, 3, 4 points. And when you look at the ordered pair of a point, we know that the first number is an x value and the second number is a y value. So x, y, x, y, x, y. Okay, so let's consider this. Do we have any x's that are cheating, seeing more than one y? Do we see the same x with different y's?
No,
No, then this looks pretty good. I'm thinking this might be a function.
because it have no different numbers.
Yeah, it's all these different x's. Now, this is where I say that we have a double standard, Stephen. A lot of people be like, but look at the repeating y's. That nobody cares. It's not the y's that matter. It's if the x is the same x is paired with more than one y. Okay, so then let's look at relation C. Students can really struggle when it's on a graph. Any thoughts about whether this one is or isn't a function?
Is it no?
It is no. You want to give me some evidence, Stephen? What about this graph made you think no?
I remember you said that you have to do a vertical test.
Cool. Stephen is remembering the lazy mathematician's way to spot a cheating, lying non-function on the graph. You do what's called a vertical line test. And this sucker just failed a vertical line test. I was able to draw a vertical line that caught 2 points on my graph here. And why does that matter? Well, let's think about what these points are. So if you're looking at a graph, well, this is the point here. Let's see, -1, -2, 1, 2, 3. So this is the point with an x value of -2 and a y value of 3. Now look at this point. Again, I'm 1, 2 back. And you guys, I'm estimating because that wasn't exactly 3, but about 1 down. So this is maybe -2, -1. It's probably a little less than that. But the idea being that I have 2 points with the same x value if I catch them on a vertical line and different y's. And so, yeah, Stephen's right. I caught that x value cheating. This is not a function. Wonderful. And yes, that is called a vertical line test. It's the lazy way to scan a graph or to check a graph to see if it's a function. Okay, so which one of these is the function? Relation B is a function. Is there anybody that was totally new to?
It's not new to me. I know I've seen this a million times, but I don't remember it.
Yeah, that's anything that's easy to learn is easy to forget. So one of the problems is when it was easy to learn, students won't practice it because they're like, oh, I don't need to practice that. It's easy. And then you go to take your test and all you can remember is this was easy.
And then you don't know how to do it, right?
Exactly. I usually only do one problem like per subject, but functions are, like I said, so easy to learn and easy to forget that I did 3 or 4 different GED style problems with them. So let's look at a few more. Which of the following points could be added to the set of points below in order to ensure that the relation described by the set of points remains a function? This is a weird question and pretty GED typical. What are they asking me to do or to find, you guys?
To add another point, but it has to stay function, right?
Exactly. They want us to add a point to this set,
But it
but
has to
keep
be.
it a function.
I can see it's the points 2, 5.
Cool. I agree with you, but just for the sake of the video, can we rule some out? Guys, is there anything here that I could not add to the set if I wanted to keep it a function? I was just looking at, for example, A. And A, to me, I could not add to this set because A has an X value of -3. And I already have a point in this set that has an X value of -3. If I were to add A, this relation would no longer be a function. So now let's consider the point that Manal was looking at. Manal thinks probably B is the right answer. B, she thinks I could add the point 0.25. Well, let's look at the point 0.25. It has an X value of 2 and a Y value of 5. Could I add that? Well, in order to figure it out, let's go consider the X values in our set. Is that going to make it so that the same X is paired with more than one Y? No, this is a new X. It's totally fine. Manal, I like that. I can add that one to the set. I'm good to go.
C also we can put it because it's -2, so we have also -2 up. Right?
Absolutely. This has a -2. This has a -2. They are paired with different Ys. This can't happen. No cheating in functions. No X is seeing more than one Y. Beautiful. There's this one that shows up on that can show up on the GED test where it looks like a table that it's already filled in. And then they tell you to fill in the blanks and they give you these list of numbers to pull from. And I see students who spend so long trying to find a pattern in the table. And all the question says is fill in a point to make it a function. So it's like way easier than students make it out to be. I'll see students spending 10, 15 minutes here trying to figure out a pattern, what's happening. And they're not asking you for that. They're just asking, put in a point and make it a function. So as long as you don't repeat the X, you're going to be good to go. So I couldn't use -1, I couldn't use 2, I couldn't use 3. I just have to plug in a 5, and then it would not matter what I put there. Any number be fine. And y'all are overthinking it. There I go with my little snake in the grass questions. Watch out for me, I'm being a snot. This time I'm asking you which of the following does not represent a function. Okay, watch out for that wording. I'm not looking for the function this time, I'm looking for the non-function. Any thoughts?
I would say C.
Why do you think that C does not represent a function? Stephen, give me some evidence.
I don't see any repeating X's at all.
He looked at B, there weren't any repeating X's.
When I go to C, I see this 2 point and the X point and the Y point, whatever.
Wonderful. So he found 2 points on the same vertical line. We just failed a vertical line test. That's a fail. This is not a function. The first time I taught functions to a classroom, it was when I was a high school teacher. I used to be a high school math teacher in Hawaii. I thought I taught functions so well, so proud of myself, sat back like, wow, I'm a genius. I'm such a good teacher. I hope you guys were taking notes. And then I gave them all a quiz, and every single student in the class got every single problem wrong. They exactly reversed the definition of function and not a function. And I was like, oh, I wasn't as clear as I
Easy to
thought.
get it confused. I think that's what my problem is. I forgot.
Well, it made me feel a little silly and also made me realize that I have to be really clear with what I'm saying for my students to understand. And so I went back and retaught that lesson, and they all did learn it eventually. Don't feel too bad for my class. But it is very easy to mix that up. So yeah, if I catch 2 points, I catch a cheating X. This is not a function. Okay, last one, I swear. Last function problem anyway. Which point would need to be removed in order for the relation described on the graph to be described as a function? They're asking me to remove a point in order this time to make this a function. So this time I've got something that is not a function, and I want to remove something to make it a function.
Point D.
Now Manal is like, Kate, take away point D. Give me some evidence. What do you not like about point D, Manal?
Because it's the same line, vertical line.
Beautiful. Look at point D and point B sitting on the same vertical line, so they must have the same X value. If I take out one of those, I will be good to go. I will have a function. So yes, we can take out point D since B isn't even one of the options. Oh, so it's easy once we get into it. Just takes a little bit to understand it. Now, this is not apparent to students how this has to do with slope or lines, but I included in this lesson because it's definitely related, and I'll explain how after we look at it. But let's go ahead and look. Letitia is planning to open a storefront from which to sell her handcrafted soaps and lotions. The realtor shows her 3 locations to consider. The first location is a 12-foot by 18-foot space in the mall, renting for $4,750 per month. The second location on a busy downtown corner is 15 feet by 19 feet and rents for $5,400 a month. The final location in the lobby of a hotel is 10 feet by 12 feet and rents for $2,850 each month. Order the 3 locations from the least expensive in dollars per square foot to the most expensive in dollars per square foot. Whoo, lots of words, intimidating for a lot of students. So help me really hone in on what I've been asked to do or to find.
Put them in order by dollars per foot.
Wonderful. We're definitely putting them in order by dollars per square foot. And the order that we're going in is the order of least expensive to the most expensive. Now, I love that Stephen specified in dollars per square foot, because I'm going to need to figure out the dollars per square foot before I can order the dollars per square foot. I can't put them in order if I don't know what they are. Let's start with that. I want the dollars per square foot of each location. So let's look at our first location. The first location is a 12-foot by 18-foot space in the mall, renting for $4,750. So this is the mall location. Notice this says dollars per square foot. Anybody know what square foot means?
Area, the area,
Area.
we have multiple.
You have to
12
multiply.
times 18.
You have to multiply. So this is a trick. I will see this again in geometry because it definitely involves a geometry concept. But yeah, if I'm talking square foot, I'm talking area. We're going to need to multiply the two dimensions here. So a 12-foot by an 18-foot location is how many square feet? Well, multiply the feet times the feet, and we'll get square feet, 216 square feet. Okay, so that's not the dollars per square feet, that's just the square feet. I'm going to write that right under that. I have 216 square feet. Okay, any other thoughts?
4,750 over 216.
Beautiful. If I want the dollars per square foot, I can start with the dollars, 4,750, and per it, divide it by, and Manal said over, which means the same thing. And I'm going to use a divide by symbol. They mean the exact same thing. But $4,750 divided by 216 will give me the dollars per square feet.
21.99.
Yeah, and it's way uglier than 21.99. It's like 21.9907, but Manal knew that this is money we're talking about. So the smallest coin we have is a penny. So we'll just round it to the nearest hundredth, the nearest cent. So $21.99 per square foot. Woo, that's some expensive real estate. They must be in the mall in Beverly Hills. I don't know what kind of word problem I was writing. Okay, so let's compare it to the next location. So we did the mall location. Now, the second location on a busy downtown corner is 15 feet by 19 feet and rents for $5,400 a month. So now we're downtown and we'd like to find the price in dollars per square foot for the downtown location.
15 times 19.
So 15 times 19 will give me the square footage of that location. It's 285 square feet.
Divided by 5,400.
I am going to divide by 285. Absolutely. I just only corrected your language, Andrea, because if I did 285 divided by 5,400, that would be this, and it would give me a really tiny answer. So I'll do the price divided by the square foot, which is, I'm sure, what you meant. Usually students don't understand the significance of order when they're talking about division. So 5,400 divided by 285, and again, we must be in Beverly Hills, because I had a restaurant in downtown Honolulu, which is a very expensive place, and it still didn't cost this much. So I got 18.9473, yada, yada, yada. And like Manal showed us earlier, we're gonna have to round again, but careful guys, this time when we round,
1890.
yeah, it's gonna go up, isn't it? I'm about to throw away a 7, which is big enough to matter. So this one's about $18.95 per square foot. So then now let's look at the final location. It says the final location in the lobby of a hotel is 10 feet by 12 feet and rents for $2,850 each month. So let's look at the hotel.
10 times 12.
That'll give us the square footage. So 10 times 12 is 120. So this is 120 square feet. Wonderful.
2,850 divided by.
So I will take $2,850 and divide by the square footage to get the dollars per square foot.
23.75.
Woo, that's expensive. 23.75. Hey, we didn't even have to round that time, per square foot. Beautiful. Now we finally have what we need in order to do what they asked us to do, which is order these from the least expensive to the most expensive. Okay, guys, which one's the least expensive?
The 18.95.
Absolutely, that downtown location at $18.95.
Then the mall.
Then the mall.
Then the hotel.
Yeah, I think we're definitely in Beverly Hills or downtown New York, or maybe we're in Dubai, but someplace with some money because these are expensive rates. Okay.
It seems like it's hard, but it's So
It's
easy.
not as bad as it looks. Well, this one's overwhelming with information.
Yeah.
So that's why I really was organized when I laid it out for you guys, because I feel like a lot of students would get lost in the steps here. But just to let you know what kind of a problem this is, the GED loves unit rates problem. Anytime they ask you to find the blank per blank. So in this case, it was dollars per square foot, but it could have been miles per hour, or miles per gallon, or dollars per day, or anything with that kind of per situation. That's a unit rate. And they love them on the GED because they show up a lot in real life. That's one reason. You can see here's a real life scenario. This is how they compare commercial properties when they're looking at it. They look at the dollars per square foot. So that's one reason they like them. But the other reason they like them is this is an application of a slope problem. A unit rate is an application of a slope. And so you don't even realize you're looking at a slope application problem, but that's what this is. And I probably have some more unit rate problems knowing me. Let's look. Yes. The line graph shows the number of patients that can be seen per workday based on the number of providers scheduled. How many more patients can be seen when 6 providers are scheduled than when there are 4 scheduled? Now, this is a much simpler, maybe we should have started with this one, but what are they asking me to do or to find?
How many more patients can be seen?
How many more, how many less? We're looking for the difference. And the difference between what? What 2 numbers?
4 and 6.
Kind of. I wish it was just so easy as the difference between 4 and 6. Then we could just subtract 4 and 6. But no, we need to go figuring out how many patients can be seen when we have 6 providers and how many patients can be seen when we have 4 providers. Can we take a look at this graph and get the information we need, since it's not apparently in the reading?
By looking at the graph, if I look at the 6 and I go up, I see 150. Then if I go to 4, it stops at around 100.
Beautiful.
So I would just subtract the difference.
Beautiful.
It's kind of like straightforward.
That one was a nice straightforward one. I'm glad you think so, because not everybody would. But yeah, just some basic graph reading, some basic understanding of difference, word problem interpretation, not so bad as some of the other line problems we see on the GED. So yay, we needed a straightforward one after the last one. It says order the following functions in order from the smallest slope to the greatest slope. What are they asking me to do or to find?
Find the slope from smallest to greatest.
Exactly. We're going to order slope from smallest to greatest. So that means we have to know how to find slope. And once again, they're being a brat to me. They gave me different ways of looking at functions. Here's an equation. Here's a table of points. Here's a graph. In order to order the slopes, you have to be able to find the slope from a equation, from a table, and from a graph. Rude. So let's get started. There's so many skills going on in this problem. It is like the culmination of everything we do in slope. Let's look at function A. This is an equation. So first of all, let me just point out that f of x confuses a lot of students. We talked about this last time. Anybody remember what f of x, it means the same as?
Why?
Y.
Why?
This is like saying y is equal to 2x. Beautiful. So this is what I say. When y is alone, you can see the slope. Because when y is alone, we are in what's called the slope-intercept form of a line. If any of you guys have your GED formula sheet, you can see the slope-intercept form of a line is on there. It says y is equal to mx plus b. M is the letter we use for the slope of a line. So what y equals mx plus b says is that if you have y alone, like I do right here, you can see what the slope is. The slope is going to be whatever number is multiplying with x. So take a look back at our equation. We have y alone, we can see the slope. The slope is whatever number is multiplying with x. What number is multiplying with x?
2.
2. This line has a slope of 2. And that's really easy if you remember it. Now, let's look here. This one, on the other hand, is not an equation. I'm not going to be able to just see the slope, okay? This time I've been given a table full of points. There's a point, there's a point, there's a point, and so on. And I'd like to find the slope. Any thoughts? Does anybody know how to find a slope when you're given information like this?
We use the y2 minus y1.
Beautiful. Manal knows that there's a slope formula. When given points, like we've been given, you can use the formula. So if you look at your formula sheet, the slope formula is m is equal to, like Manal said, y2 minus y1, the change in y's, over x2 minus x1, the change in x's. Okay, Manal, so we are going to need to, if we're using a formula, plug into the formula. So you're going to need to decide what points you'd like to use.
We can use any numbers, right? Any numbers like 4, 5, 6, 4, or
it doesn't matter as long as you're consistent about which you call point 1 and which you call point 2. So like we could call this one point 1.
4, 5, and 6, 4.
And sure, we could call that point 2. So let me bust out a different color. Because if this is point 1, then this will be the x1 and this will be the y1. And if the other one is point 2, then that'll be the x2 and that'll be the y2. That little subscript 2 isn't math to do, it just means first or second. So there's my first x, there's my second x. There's my first y, there's my second y. That's all I mean by that. So let's plug into our formula then. What is y2, my second y value?
4 minus 5, 6 minus 4.
Beautiful. My second y value is 4. And from that, I am supposed to subtract my first y value. And as Manal said, my first y value is 5. Beautiful. And then she got all the way down to my x's. My second x value, well, we said that was 6. And from that, I'm supposed to subtract my first x value, the 4. Now what?
Minus half. Minus 1 over 2.
Wonderful. She's already simplified it. Now, I'm going to do it according to the order of operations, which says to work in groupings first. So the top of a fraction makes a natural grouping. 4 minus 5 is -1. And that's supposed to be over the grouping on the bottom. 6 minus 4 is 2. And so like Manal said, I get -1/2. Now do remember that all final fraction answers should be reduced to lowest terms. But this is already reduced. I can't make 1/2 any simpler than it already is. So that is a slope of -1/2. I am putting together 5 different slope lessons in one problem. So if you feel like, oh my God, this is a lot. Yeah, it is. Okay, then let's look at function C. Again, I'm trying to find the slope, but again, they gave me something different. What did they give me this time? What am I looking at?
A graph.
A graph. Anybody know how to find slope off of a graph?
Is it rise over run or something?
Beautiful. The quick, easy way on a graph is, again, to find the change in y over the change in x. We just call that the rise. That's how much your y is changing. It's your vertical movement over the run. That's how much your x is changing, your horizontal movement. So we're going to start here and we're going to see how much we rose. And oh, I just jumped over where I was starting. It doesn't really matter where you start, guys. I just start on a point that I can recognize. So you can start at any point on the line, okay? So there, I started there and I'm gonna rise and run to go to this point over here. So how much did I rise?
4, you rise 4.
Oh, you're counting boxes, aren't you? So I rose 4 boxes, sure. And then I ran how much?
6.
1, 2, 3, 4, 5, 6, 6. Okay, beautiful. So I get 4 over 6, which reduces,
2 over
those
2.
both have a common factor of 2 to 2/3. But even if you don't know that, you can do it in your calculator. 4 over 6 by inputting n over d, 4 over 6, and then pressing enter, it would reduce it for you to 2/3. Okay, so here I have 3 slopes. 2, -1/2, and 2/3. And I'm supposed to order them from smallest to greatest. Which one of these 3 lines has the smallest slope?
-1/2.
Yeah, negative numbers are always smaller than positive numbers. Okay, if I'm just talking least to greatest, yeah, a negative number is going to be less than a positive number. So my function B has the smallest. Then the next smallest slope is
Graph 1.
a graph. 2/3 is something, you know, a little smaller than 1 there. And then finally, my largest slope then would be A. Of course, a slope of 2 is larger than 1, much larger than 1. So I'm good to go. B, C, A. Woo! And again, all the slope information put with comparing functions in one problem. Very GED style tricky. If you've never done slope before, this was jumping in the deep end and I just like threw you in and hoped you wouldn't drown, you guys. So like I said, on the crash course, I have literally 5 different lessons on slope. There's one where you just practice it on a graph over and over again. One where you practice it using points over and over again. One where you practice it on an equation over and over again. There's another one from word problems too. And then finally, there's a review where you can practice like all these mixed up ones. That's the hardest they get today, so. Okay, let's look at this one. A pair of hikers were at an elevation of 1,100 feet after hiking for 3 hours. After 5 hours, they are at an elevation of 900 feet. If their elevations in respect to the time they have spent hiking were plotted on a graph, what would be the slope of the resultant line? What am I asking you to do or to find? They're asking me to find slope, but this time, because I have a word problem, it's a lot harder to see what I have. Obviously, it's not a graph, but what is it? What do I know here?
We have the 11 feet and the 3 hours. It's the points that we
That's
added.
a point. Beautiful. We have the relationship between feet and hours. It's a point. And then we have another point, don't we? We have another relationship between hours and feet. So we have 2 points. Manal's right. But super duper important, you get the points in the right order. We need the input variable, the independent, to come first, and the dependent variable, the output, to come second. So would it be the point 1103, or would it be the point 3, 1100? And it does make a difference. Any thoughts? Does anybody know? It actually doesn't matter what order they presented it in the word problem. It matters which thing affects the other. So is it the time that affects how far up the mountain you are, or is it how far up the mountain you are affects the time? Like if I climb another feet, can I change the time? Or is it that as the time changes, my elevation changes?
The time is changing.
There we go. So it's actually 3. As the time changes, it affects my elevation.
Because
Okay, that's the independent variable. It moves on its own. And that's the dependent variable. It gets affected, or the X and the Y. Okay, so then let's look at the other one. After 5 hours, they are at an elevation of 900 feet. That's a point. What point is it?
it will be the same. 5.
Yeah, it'd be the same. After 5 hours, I'll be at 900 feet.
Is it feet per hour?
Stephen, you weren't thinking about it as a point. You were thinking about it as a slope, right? I heard you say it would be the feet per hour. Yeah, it would be the feet, the number of feet we change per the hour. The change in Y, feet are our Ys, per the hours, that's the change in X. Our hours are our X's. So it doesn't matter which way you think about it, you'd get to the same answer. So you had some good reasoning going on there. And whether I use the formula or not, I'm still going to do the same basic thing to get feet. So in the slope formula, we said we would take the second Y and subtract the first Y. Okay, so in this case, that's our change in feet. You know, we started at 1,100 feet and oh, sorry. I was about to screw some crap up, you guys, because I'm supposed to start with Y2, my second Y. So 900 feet, we ended at 900 feet, and from that I'll subtract where we started, 1,100 feet. Beautiful. That's my feet. And then Stephen said that's per hour, so I need my change in hours. How long did it take me to do that? Well, I ended at 5 hours. That's my X2. And from that I can subtract my first X, my 3 hours. So it was over the course of 2 hours. I went down 200 feet.
It's minus 100.
Yes, exactly. That's a slope of negative 100. I'm going down 100 feet per hour. Now, I did it with a formula because I'm a mathematician, but not many of you guys like the formula method. You can always do it like what Stephen was saying to me. How many feet did I go per hour? Well, I went down 200 feet over the course of 2 hours. Negative 200 feet divided by 2 hours, and I get negative 100 feet per hour. I almost want to do this like a student would do it instead of like a math teacher would do it, because I just did it like a math teacher through and through. I made points, I wrote a formula, but that's not usually the easiest way for students. Are you guys okay with me erasing this and doing it one more time a different way?
I'm okay with it.
So what are they asking us to do or to find here? They're asking us to find the slope of the resultant line. But guys, remember that slope is just a rate of change. I'm looking here at a hiker hiking. As he hikes over time, his elevation is changing. You know, he's starting at an elevation of 1,100 feet once he's been hiking for 3 hours. And then After 5 hours, he's at 900 feet. As he hikes, his elevation's changing. We're looking for his rate of change. We're looking for how his elevation changes in an hour. We want the elevation change per hour. So don't get thrown by math words like slope. Slope literally means rate of change. Remember how we were saying any something per something is a slope, a rate of change. So let's figure these two things out. If we could just figure out the elevation change and the number of hours he's hiking, we can figure out the elevation change per hour. So guys, elevation change. How much did this dude's elevation change? How about let's go with starting and ending. Where did his elevation start? What was his starting elevation here?
1,100 feet.
It started at 1,100 feet. Beautiful. And where did it end?
900 feet.
900 feet. Beautiful. Okay, so starting at 1,100 feet and ending at 900 feet is a change of how much? How much did his elevation change?
200 feet.
200 feet, absolutely. And we use signs in math to tell us if we went up or down. Stephen, did he go 200 feet up? Is that a positive 200? Or did he go 200 feet down? Is that a negative 200?
Be negative.
Absolutely. He descended, he went down 200 feet. If he started at 1,100 feet and went to 900 feet, he changed, he went down 200. And we're going to per it, we're going to divide it by the number of hours he was traveling. How long did it take him to make that elevation change, you guys? Notice that they were at the 1,100 feet after hiking for 3 hours. And then they were at the 900 feet elevation after hiking for 5 hours. How many hours have passed?
2.
Exactly. That's a change of 2 hours. So we made that negative 200 foot change in the course of 2 hours. And now we can just do that division. Negative 200 divided by 2 is just negative 100. So I'm going down 100 feet per hour. That's all slope is a rate of change. In this case, the number of feet I'm changing each hour. Does that way make more sense than the other way I did it, like a mathematician?
Yeah, it's easier. It's more straightforward.
It's funny because the other way to me is more straightforward, but that's because algebra is my language, right?
I like the first one.
That's okay. It don't matter. So many teachers get caught up in you doing it my way. I don't care which way you do it. I just need you to use some truth and some reasoning here. And I have a whole lesson on just doing this. It's slope from word problems. I have a ton of examples. Okay, let's look at this one. The graph models the height, h, of a model rocket launched from the roof of a 30-meter building t seconds after launch. Find the average rate in meters per second the rocket was descending in the interval between 6 and 8 seconds after launch. What in the world? What are they asking me to do or to find?
Find the average rate in meters per second.
Good. And it's for a specific part of the graph. They want us to find the average rate in meters per second that the rocket was descending in the interval between
6 and 8.
So from here to here. This might look a lot different. They might not be telling you. It's not even a line. But you know what they just asked you to find? Average rate of change. They're looking for slope. Guys, this is a slope problem again. Okay. And we can see again the meters per second, that idea of unit rates coming up in slope again. So we can do it again, just like the last problem could be done 2 ways, using the formula or using our common sense. We can do the same thing here, the formula or the common sense. It'll get us to the same place, okay? As I moved from here to here, how many meters was that? They asked me to do it in meters per second. So I have my meters up here and I'm gonna do that per seconds. So how many meters? Well, this one I'm at, let's see, height of rocket in meters. I'm at 294 meters. And this one I'm at 126 meters. So how much meters did I change by?
168.
168. Where'd you get that number?
Subtract the two, both of them,
Subtract the two.
Yeah.
Wonderful. So Manal used the formula. Guess what the formula says? Subtract the two. Andrea is using some common sense about change. If you want to find change, subtract the two numbers. I don't care whether you use the formula or use common sense. You still are going to take the ending value, 126, and subtract the starting value, 294. Okay? And notice, like Manal said, I do get 168, but it is a negative 168. And I think it should make sense that it's negative. Looking at the graph, why does it make sense?
It's going down.
Yeah, I'm going down. My rocket's falling. Okay, it's descending. So I descended 168 meters. In how many seconds? How many seconds was that?
2.
Absolutely. I ended at 8 seconds. I started at 6 seconds. The difference between 8 and 6 is that's a 2-second difference. Beautiful. And you got what, Manal?
84. Minus
84.
84. Negative.
It is negative
Yeah,
84 meters
negative
per second.
84.
Although you
Yeah.
might be mad at me, none of my answers say negative, but that's because it says find the average rate the rocket was descending. So the rocket was descending 84 meters per second.
So the negative, you don't need to put that negative.
So there's 2 ways to say the same thing. You can say that it was descending, it was going down 84 meters per second, or you can say it was descending 84 meters per second. But you'd never put both in the same answer, because if you put both, you'd be canceling yourself out. If you said it was descending at a rate of negative 84 meters per second, then you're saying you're doing the opposite of descending. You're actually sending a message you don't mean descend, that you're going up. So since the word descending was already in the problem, I'm just going to put I was descending at 84 meters per second. So don't send the same message twice. Either it gets said in English or it gets said in numbers, but we're not going to say it twice or we're going to cancel it out. Rough. Again, another slope problem didn't look like a slope of a line problem. Didn't even have a line. Write the equation of the line in slope-intercept form. What are they asking me to do or to find?
The slope intersect form.
The slope-intercept form of a line. They're asking me to write the equation of a line. Now, yay, our GED formula sheet has this on it. I said it in the video, yes, but it's also on the formula sheet, so you don't have to have it memorized. What is the slope-intercept form of the equation of a line? Hit up your formula sheet if you don't know it.
Y equals mx plus b. That's not one formula that I know by heart.
I'm glad you know that one, Stephen, because even though they give it to you on the GED, your college algebra teachers are going to expect you to know it by heart. And when you go to take that college placement test, like most of you will after your GED, you need to know y equals mx plus b, okay? And so for those of you who don't know it by heart like Stephen does, I have a trick to remember it. I say, why am I always alone? See, the y is always alone in this one. Even my x is married. See Mrs. X? There she is. She's such a slope with a baby. So why am I always alone? Even my ex is married with a baby. You guys, I was single for 37 years, so I was a very lonely math teacher. The idea here is that if you have your y alone, you can see 2 things. You can see the m, and earlier we said that m stood for what? Mathematicians use the letter m to stand for what in this case?
Slope.
Slope. And you can see the b. Does anybody know what we use the letter b to mean?
Why?
The y-intercept. Not a y value, but the y-intercept, where my line crosses the y-axis. So I can see the slope and the y-intercept when my y is alone. This is really wonderful to us because now I can just look at my graph and find the slope and the y-intercept. Let's start with the y-intercept because it's easier. Do you know how to find it on a graph?
Where it crosses the y-axis.
Yeah, it's where my line crosses the y-axis. Where is that?
2.
2. Beautiful. So I have a b, a y-intercept of 2. I'm going to have a 2 plus b plus 2. Wonderful. And then we've already been doing slope off of a graph. Stephen said when we're doing slope off a graph, we can rise over run. What's the slope of my graph?
Minus 2 over 4.
Beautiful. It's negative 2 over 4. Negative 2 over 4 will reduce to negative 1/2. Yeah, D, there we go. This one has a slope of negative 1/2 and a y-intercept of positive 2. So to take a line from its generic form, y equals mx plus b, that's the equation of any line, to a specific form of a single solitary line, you have to know the slope and the y-intercept.
I need to review this again though.
Yeah, it's another one. Everything in the lines chapter is like this. Nothing is that hard, but it's all, do you know it or do you not know it? So it's super easy to forget. So the topic here is writing equations of lines. And I have a lot of practice in all different forms up on the crash course and even more to come that I've been working on.
Let's look at this very GED typical problem here. Raphael is doing some improvements in his yard this summer. He wants to build a rock garden in his front yard. 3 companies in town offer the gravel he wants to spread out in the front yard. Order the companies from least expensive to most expensive in price per cubic foot. So again, let's go ahead and look at what they're asking us to do or to find. We see that in the last sentence there. It says, order the companies from least expensive to most expensive. So once again, we're doing what they call comparing functions or comparing unit rates on the GED. But notice they tell us what they want us to compare exactly. They say they want us to compare it in price per cubic foot, price per cubic foot. So we can't compare these things until we know these things. So let's be really neat about our work and make sure we find the price per cubic foot in each scenario. So let's look at Rocky's rock first. Take a look at what we see here. I see 2 columns in this table. First one is the feet abbreviation with this little 3. And guys, that's not math to do or anything. That's just the shortcut abbreviation for cubic foot. And then of course you see the cost, and cost is synonymous with the price. So if I want to find the price per cubic foot, I need to start with a price and per it, divide it by some number of cubic feet. Now you might say, well, but Kate, which line do I use? There's a lot of prices per cubic feet here. And if you're asking yourself that, it's probably because you don't understand something about these linear functions that we see on the GED, and that is that they're consistent. That's what makes it a linear function. That's what makes it draw a line, this wonderful consistent rate of change. And so it won't matter what line you use, you'll get the same answer, okay? So I'll just use the first one because why not? So if I want to do price per cubic foot, I'll start with the price, $65, and I'll per it, I'll divide it by the cubic feet, in this case 50. And now let's see what we get. Okay, so 65, I've got my GED calculator out, divided by 50, and I get this interesting number, 1.3. Now let's make sense of that in this context. That's 1.3 what? Well, I was dividing dollars by cubic feet, so that's 1.3 dollars. But that's interesting. We don't usually say 1.3. When it comes to money, yeah, we're going to need to add a 0 at the end to make sense of this. That's $1.30 per cubic foot. Cool, we found the first one. Now let's look at the next one. I can't even emphasize it enough, star it, highlight it. This is the one most GED students mess up. They don't know where to look. Now, once again, it's a line. So it really doesn't matter where on the line you look, but you need to be on the line. When I first did this problem with the students in the Math 144 class, I had to throw out that video footage because the audio was horrible. But anyway, when I first did this problem with them, they had no idea. They were just guessing numbers left and right. And so let's really hone in on the graph. We could be anywhere like on this graph and get our numbers to figure out the price per cubic foot. But a good general rule of thumb on a graph, when it's hard to tell what the exact numbers are, the bigger you go, the better, because little issues in estimation don't make such a big difference when the numbers get bigger, whereas it makes a big difference when the numbers are smaller. So I think that I will go right here from the 400. It's easy to see. I'll get up to the line and I'm about here, and now I'll come across and say, okay, where am I? Well, I'm between 400 and 600. I'm closer to 600 than I am to 400. And again, I'm using my estimation skills. Well, about halfway between them would be about 500. So I don't know, maybe I'm at 550. So that's about a 550 cost. See, that's the cost axis. And I'm going to take the price per cubic foot. So I'm going to divide or per by the cubic feet. That's 400 cubic feet. So I'll divide by that. So 550 divided by 400. And again, this is an estimation, but that's okay. They won't be so close that you won't be able to tell using your estimation. I got out of my calculator this number, 1.375. Again, this is money. I need to make sense of it as money. So it'll end at 2 decimal places. So I'll round it there. So that's about $1.38 per cubic foot. A little more expensive than the last guys. Now let's look at stone-faced. At least stone-faced is easy. Hey, it's $300 for 250 cubic feet. Nice. So if I want the price per cubic feet, I just need to take the price, $300, and per it, divide it by the cubic feet. This is a construction abbreviation for cubic feet. Mathematicians write this, And in construction, they tend to write that. So 300 divided by 250, and I get 1.2. Again, if you need to make it longer, you add the 0 on the back side. So that's $1.20 per cubic foot. Okay, so we're supposed to order the companies from least expensive to most expensive. So who's the least expensive? Oh, that'd be Stone Faced at $1.20. Next would be Rocky's Rock at $1.30. And then finally the Gritty Gravel Company at $1.38. And I cannot stress enough how this is GED typical. That's why I couldn't just throw this footage away without doing this problem. You guys need to see this. This is comparing slope or comparing functions, comparing unit rates. It's all three of those things. And it's always on the GED, something like this.
That's my last problem I have for today. Thank you so much for joining me for this slope functions and line review. And join us next week when we do geometry for the GED. See you next time.
I just can't stress enough how important practice is to learning math. So don't just stop here at watching a video. Head on over to my website, the GED Math Crash Course. Link is down there in the video description. And get your practice on. Check your answers. Make sure you're ready and prepared come test day. And I just want to thank everybody who supports this ministry of helping students who've long struggled be able to finally get their GEDs and pass this test. It really is making a difference. And so thank you to those who support me on Patreon. Thank you to those of you who've bought me a coffee, as they say. And if you want to be able to do that, I've got the URLs up here on the screen. And just from the bottom of my heart, I so appreciate you supporting the work that we're doing. Happy learning.